This is the Unit 2 Practice Exam A for Trigonometry Math 1060. Question number one, we have linear speed and angular speed. The question that we need to answer is what is the angular speed? That's what they're asking here. How fast are the wheels turning in radians per second? So if you recall from section 2.3, the formula that relates linear speed to angular speed is radius times omega. So we need to solve for omega here by dividing by the radius. Now, a couple of problems we have though, the units of measure, the speed here is 60 miles per hour. So we have miles in terms of hours, and then the radius is in terms of inches. So we need to do some unit analysis here to convert miles to inches and hours to seconds. So if we have 60 miles per hour, first going to convert to, let's do seconds. So 1 hour is 60 minutes. And then we can convert minutes into seconds. So 1 minute is 60 seconds. And then we can convert miles into inches. So we have 1 mile, it's 5,280 feet. And then we can convert 1 foot is 12 inches. So this is going to put 60 miles per hour in terms of inches per second. Because feet cancel, miles cancel there. Let's see, hours, minutes. So there we go. We have inches per second. And this turns out to be 1,056. 1,056 inches per second. So now we can take that speed divided by the radius. This is inches per second. This is inches. So inches are going to cancel out, leaving us uh, a unit of measure per second. It turns out to be radians per second. And this is about 58.67 radians per second. Question number two, find the exact value of cosine 165. So typically when we've found the exact value of a trigonometric function has been on a unit circle. 165 degrees is not one of the special angles on the unit circle. So what needs to happen here is using one of the identities learned in unit 2, either the double angle, the half angle, or the sum difference formulas to convert cosine of 165 into a different expression. So I'm going to use the sum formula for cosine. Cosine of 165 can be cosine of 120 plus 45. And then the identity for that is cosine 120 cosine 45 minus sine 120 sine 45. The cosine of 120 is negative 1/2. Cosine of 45 is root 2 over 2. Sine of 120 is root 3 over 2. And sine of 45 is root 2 over 2. So this is negative square root of 2 minus the square root of 6 divided by 4. Okay, arc length is the formula S, which is arc length is equal to the radius times the angle. Angle needs to be in radians. So first thing is to convert 150 degrees into radians. This would be 5 pi over 6. So now we just use the formula radius times the angle theta. Five inches times 5 pi over 6 equal to 25 pi over 6, which is approximately 13.09 inches. All right, question 4, we need to find and evaluate the sine of alpha plus beta. So this is going to be the sum formula for sine. So sine alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. So we need to figure out the sine of beta. So if we know the sine of alpha is -1/2 and alpha is in quadrant 4, we need, from that information, we need to find the cosine of alpha. So if we use the right triangle definition of sine, this would be the opposite length over the hypotenuse. So we need to find the adjacent length using Pythagorean theorem. So if we have the unknown length of the triangle a squared, and then b squared equals c squared, then we have 2 squared is 4, subtract 1 from 4, we have 3. So a squared is equal to 3, which means a is equal to the square root of 3. So then the cosine of alpha is square root of 3 over 2, and then in quadrant 4, cosine's positive, so we're going to keep that as positive root 3 over 2. And now we need to do the same thing. If we know that cosine of beta is equal to negative square root of 3 over 2, then again, right triangle trigonometry, this could be the adjacent length over the hypotenuse. So we need to find the opposite length. We'll still do Pythagorean theorem. So negative square root of 3 to the second power is 3. 2 squared is 4, so if we subtract a 3 from 4, we get 1. So b squared equals 1, which means that b is equal to 1. So then the sine of beta is 1/2. And if this is in quadrant 3, sine is negative in quadrant 3. So then we can use this formula here, this identity, and replace sine alpha and cosine beta and so forth with their values here. So sine alpha is -1/2. Cosine beta is negative root 3 over 2. Cosine alpha, positive root 3 over 2. And sine beta is -1/2. So this is square root of, this is the square root of 3 over 4. This is the square root of 3 over 4. So this is going to equal 0. Looks like we're going to have positive root 3 plus negative root 3 all over 4, which is, yep, 0. Question 5. The double angle identity for sine. So we have sine 2 alpha is 2 sine alpha cosine alpha. So now if the cosine alpha is -3/5, then using right triangle trigonometry, we have a squared for the adjacent and the hypotenuse. We need to find the opposite length. So one of the sides of a right triangle is missing, so we can do Pythagorean theorem, a squared plus b squared equals c squared. This is 9, this is 25. Subtract 9 from 25, we get 16. So a squared equals, let me do this A squared is equal to 16. That means that A is equal to 4. So the sine of alpha is 4/5. Now, alpha is in the second quadrant between 90 degrees and 180 degrees. So in the second quadrant, sine is positive. So we're going to keep this as positive 4/5. So now we can evaluate that identity. Sine alpha 4/5. Cosine alpha is negative 3/5. So this is 2 times 4 times negative 3. That's negative 24 1/5. Okay, the half angle identity for cosine. Oh, it's going to be either the positive or the negative of the square root of 1 plus cosine alpha divided by 2. So if alpha is in between 180 and 270, then alpha divided by 2 is going to be between half of 180, which is 90, and half of 270, which is 135. So 90 to 135, that's in quadrant 2. Cosine in quadrant 2 is negative. Okay, so now we can evaluate. They're telling us here that the cosine is negative 7/25. 1 plus negative 7/25 is 18/25. So this is 18 over 50. If we simplify that, we're going to get 9/25, which is negative 3/5. Question 7, we're going to graph tangents. We need to know the period. Period of tangent is pi divided by b. In this case, b is 2. So it's pi halves. The period is pi halves. There hasn't been any horizontal shifting to the left or to the right. So typically on a tangent graph, the cycle that we graph is the one that's centered here on the origin. That means there's 2 vertical asymptotes on either side. Now, typically with a tangent function with no change in the period, it's been from negative pi halves to positive pi halves because that distance is equal to pi. The period has been cut in half, so we're gonna need to also cut those asymptotes in half. So instead of negative pi halves to positive pi halves, it's going to be negative pi fours, positive pi fours. Okay, secant, and I need to know the length of the period. So it's 2 pi divided by b. B is 1/2 right here. So 2 pi divided by 1/2 is 4 pi. The phase shift is the opposite of c divided by b. This is going to be positive pi divided by 1/2, which is 2 pi. So we're shifting to the right 2 pi units. So let's say we start here at 2 pi, and then the period is 4 pi. So starting from there, we have to go a distance of 4 pi. So that would actually end us here at 6 pi. So this accounts for that phase shift, and then 2 pi to 6 pi accounts for length of the period. Well, then midpoint there would be 4 pi, and then the amplitude is 3. So to graph a secant, if you remember, we first graph a cosine function. The cosine function starts at the top, above the midline, the top of its amplitude. So it's right here. And then in the middle of its period, it's at the underneath the midline. And then at the end of that cycle, it's at the top. So this is what the cosine graph would look like, at least that particular cycle between 2 pi and 6 pi. And then every time that graph would cross through the x-axis, that's where one of our vertical asymptotes would be. And then the secant graph is actually these parts that are graphed in bold. Question 9, amplitude is 2, period, 2 pi divided by 2, and the phase shift is the opposite of c divided by b. So this is going to be pi halves divided by 2, which is pi fourths. And then one complete cycle of that. So we need to account for both a phase shift and a vertical shift down 3 units. So the phase shift is pi fourths of a unit to the right. So let's say this is pi fourths. And then we shift down 3 units. So I'm going to create a new vertical and horizontal axis centered around that point. It's been shifted to the right and down 3 units right there. So starting at pi fourths, the period is pi. So if we go out a distance of pi units, let's say that's pi units, from here to here is pi units, but if we started at pi fours and we travel the distance of pi units, which is 4 pi over 4, and we add 1 pi over 4, then we're going to end at 5 pi over 4. And then the midpoint here is, instead of going a full period of pi units, it's pi over 2. So if we have pi fours and we add pi over 2, which is 2 pi over 4, we're going to get 3 pi over 4. And then the amplitude is 2. So from the midline here, we're going to go up 2 units and down 2 units. Sine function starts at the midline. All right, question 10. We're going to verify this identity. I'm going to choose the left side here. And then I'm going to use the tangent sum identity.
Okay, now the problem I'm seeing here, this is kind of a big problem. Tangent of pi over 2. Pi over 2 is 90 degrees. The coordinate location there is 0, comma 1. The definition of tangent is y over x. The x coordinate at pi halves or 90 degrees is 0. We can't divide by 0. So tangent of pi halves here and here is undefined. So, okay, unfortunately this approach isn't going to work. So let's try using the ratio identity. Tangent is equal to sine over cosine. So if we do sine of theta plus pi halves divided by cosine of theta plus pi halves, now we can apply the sum identities for sine and cosine individually in the numerator and denominator. So for the sine of theta plus pi halves, we have sine theta cosine pi halves plus cosine theta sine pi halves. And then for cosine, I'm going to do cosine theta cosine pi halves minus sine theta sine pi halves. Now at pi halves or 90 degrees, the x value is 0, so cosine is going to be 0. Cosine of pi halves is equal to 0. So this term here, sine times cosine, becomes 0, as well as this one, cosine theta times cosine pi halves is also, so this whole side disappears. So what we're left with is cosine theta sine pi halves, and then we're left with this part here, sine theta sine pi halves, and then these two are going to cancel each other out. So we're left with cosine theta over sine theta with this negative sign that carries over, and then the definition of cosine over sine is cotangent. So this is negative cotangent theta.